Heat and temperature are fundamental concepts in physics and thermodynamics. They may sound similar, but they are two distinct concepts that help understand how energy is transferred and transformed in the physical world. Heat is related to thermal energy and is measured in joules. Temperature measures the average kinetic energy possessed by the molecules within a material or system. It is commonly measured in Kelvin, Celsius, or Fahrenheit. Let's look at an example. While heating a kettle of water, water molecules start moving vigorously and become less dense. These moving molecules possess kinetic energy, and this kinetic energy increases due to the supplied heat energy. We can measure this increase in kinetic energy in the form of temperature. Thermometers measure the increase or decrease in temperature. Now let's discuss the relative values of Kelvin, Celsius, and Fahrenheit scales. 0 Kelvin is called absolute zero. Absolute zero is the temperature at which molecular motion stops. In other words, the temperature at which the molecular kinetic energy becomes zero. Its corresponding values in other scales are minus 273 degrees Celsius and minus 459 degrees Fahrenheit. Water freezes at 0 degrees Celsius, average human body temperature is 37 degrees Celsius, water boils at 100 degrees Celsius. Now coming to heat. Heat is the transfer of thermal energy between objects or molecules within a system. It is measured in joules. An object or system either gains or loses heat. It can't have heat on its own. In other words, heat is the measure of change and not a property possessed by an object or system. Heat is the transfer of thermal energy caused by the difference in temperature between molecules. For heat transfer to take place, the object should be in thermal contact. Heat always flows from hot to cold objects until the temperature reaches equilibrium. Transfer of heat results in an increase or decrease in the internal energy of the objects involved. Transfer of heat can happen by three methods: conduction, convection, or radiation. Each method differs in the way heat is transferred. To understand things better, let's go by an example of heating water on the stovetop. Conduction. In this method, for heat to be transferred to one object, it must be in contact with the heat source. In this example, the vessel is in contact with the flames, which is the heat source here. When you touch the hot vessel with bare fingers, it will burn you. This is because, due to conduction, heat is transferred from the vessel to your finger when you touch it. Convection. Convection is a method of heat transfer which happens due to the movement of fluids or gases. When the water in this vessel boils, it gets converted into vapor. When you place your hand directly over the vessel without touching it, you will feel the heat. This is called convection. Here, the vapor, which is the gaseous form of water, transfers the heat from the vessel to your hand, though you don't physically touch the vessel or water. Now, radiation. Radiation is the method of transferring heat through electromagnetic waves. Think of a campfire. Though you stand away from the flames and not touch any of the embers, it still keeps you warm. How? There is no movement of molecules here. It is radiation. The heat from the flames reaches you through electromagnetic radiation. There is another real-life example for radiation: the sun. The space between the Earth's atmosphere and the sun is void without molecules. Then how does the heat from the sun reach the Earth's surface? It's electromagnetic radiation. The microwave oven you use to reheat your food works by electromagnetic radiation. The OTG you use to bake your cookies works by convection. Your electric kettle heats up liquid by conduction. Interesting, right? From space to our kitchen, the heat transfer plays a vital role. Next time when you see a heat transfer process, think whether it is by conduction, convection, or radiation. Thank you for watching this video. For more such infotainment videos, subscribe to Black Story.